This video will explain finding the GCF for a set of numbers like 45 and 75. You probably noticed that those two end in 5. Using our divisibility rules, we know that if it ends in 5 or 0, it's divisible by 5. So 5 goes into 45 9 times. 5 goes into 75, I really don't know. So I should not do it in my head. I should divide. And it goes in 15 times. Now some little guy might be sneaking around on you thinking that you're not going to catch him, but 3, you got it, goes into both of these numbers. And when we get down to 3 and 5, they're both prime. If you have 2 prime numbers at the bottom, you're done. And you're also done if you have other numbers that don't have anything in common except for 1. And so you circle and multiply. So our GCF is 5 times 3, or 15. Just like that, we can use GCF to reduce fractions the quickest way possible. If that 45 was on the numerator and 75 is the denominator, we would divide both of those by 15, which is their GCF, to get to the reduced fraction as fast as possible. 45 divided by 15 is 3. 75 divided by 15, I don't know that one. I won't do it in my head. I know that maybe it's going to be around 5 or 4. Five was correct, meaning that's 3/5 as its reduced fraction. Remember that up here we already had 3/5, so that's like our cheat. Let's do one more. This one I'm going to start with the fraction. I want to reduce 24 40ths. Okay, let's put them both in a division ladder. They're both even, so I know 2 goes into them. Again, both even. Two goes into 12 6 times, 2 goes into 20 10 times. Again, both even. 2 goes into 6 3 times, 2 goes into 10 5 times. Now I'm done because 3 and 5 have nothing in common except for 1. Therefore, 3/5 is my reduced fraction that was 24 40ths. How do I know you're right, Mrs. Gormel? You know I'm right, not just because I'm a teacher, but because if you multiply 2 times 2 times 2, we know our GCF is 8. If I do 24 divided by 8, and I do 40 divided by 8, I should get to 3. I do. 5ths. I do. Checks our work, and it works. Very good.